Ladies and gentlemen, at 2025, the pinnacle of education, today we will be discussing the secret of evolution and diving deep into ways it works and operates. First of all, to make it easier to understand the concept of evolution itself, we are going to be dividing it into four segments, four smaller segments. First one being natural selection. In natural selection, the key idea is that nature selects the best physical traits the best natural physical traits that fit the animal or the species the most. So in the natural selection, it's like a survival game, and it really is like a direct definition for the phrase that said like only the strong ones survive. So natural selection is completely that, kind of harsh, but the true reality of this world is a survival game. For example, we have the example of gazelles. Imagine a group of gazelles. Some of them are fast and some of them are fairly slower than the others. When a predator attacked, the slow ones are going to be behind the faster ones and going to get eaten. So only the faster ones are going to survive that attack. And those faster ones are actually leaving their offspring, and the next generation of gazelles are actually being faster than the previous generation that existed. So they are fitting their environment better. We have the second segment for evolution, and the second one is mutation. In mutation, also known as, I call it that, it's like hope for the best, random DNA lottery. Because, well, in mutation, random change in DNA happens, and you cannot really say what will happen. You cannot like predict what's going to happen. So it could be bad. Most of the times, it's very bad. And few lucky mutations actually help your survival, actually help you fit your environment better. For example, we have an example of mice. There were population of gray mice living on the black rocks. However, mutation happened, and a child rat with a black fur was born, and that mouse actually fit its environment better. Randomly born and actually fit its environment better. So it has a better physical trait than the other mouse that lived before it, than its parents, and now the new generation of mice are going to be black because the grey mouse are not actually the perfect ones to survive. Mutation is actually a very interesting topic, so I just want to give out another example, and that being the blue eyes. Once upon a time, 6 to 10,000 years ago, to be more precise, a single man in Europe was born with blue eyes. And that happened to be the starting of the population of the blue-eyed people. Well, actually, it was a random change in DNA that didn't affect his or that people's physical traits or survival in a bad way, because that was just a color change in color, so it didn't affect it in a bad way. So it just stayed there with us, and it could actually have helped those people in Europe in a very good way, because, like imagine, the blue eyes have less melanin amount in them, so it's actually very good to absorb the sun rays, because it's actually better than the brown eyes at that point, at that specific task. It's better. And of course, the reason those blue-eyed people like scattered across Europe is because people actually found those guys with blue eyes kind of rare and attractive. That's the reason. And we have this segment that we are going to discuss, and that is going to be adaptation. Adaptation is like nature's upgrade system. Adaptation happens over many generations. It's going to happen over millions of years, maybe. It is a very long process, and it shapes a species or an animal to fit its environment better. Yeah, so I could give you polar bears as examples. So thousands of years ago, the polar bears were actually brown. Did you believe that? Did you believe that? They were brown, but however, they weren't camouflaging good in the snowy areas and white environment. They weren't camouflaging very good. They couldn't like sneak up on their prey because imagine 3 feet long bear coming at you, brown color, everything white. I mean, yeah, they couldn't sneak up. They couldn't do nothing. They couldn't camouflage. So they were bad, they couldn't fit their environment. However, they adapted to the snowy environment, to the white environment, and therefore actually became white over many generations. And those white polar bears survived, and those brown polar bears, are now like long forgotten. Yeah, so for evolution, our final segment is going to be the genetic drift, or the lack of the draw. So in genetic drift, sometimes evolution happens just by pure luck. Just by pure luck. The next species is going to be like remaining because it was lucky. For example, there was a pond. And it had frogs of all colors. For example, imagine that it had frogs of all colors, and suddenly a flood happened. It's a random flood, and it happened, and only the surviving ones, almost all the surviving frogs were green frogs, not because they had better physical traits. They had the same physical stats as the other frogs. They didn't have anything else. They were just lucky. So when the flood happened, those green frogs survived by their luck. And the next generation, next species of the frogs are going to be green because they're lucky. That is the last segment of evolution. So now that we have understood the concept of evolution, at least generally, now we can have some interesting and amusing examples for evolution happening. First one being leaf insects. So imagine over millions and millions of evolution. Over many generations, these insects could have developed anything, could have developed saber tools, razor blades, or anything else, but they didn't choose that. They evolved to look like a leaf, to look like a literal leaf. So that's how evolution works. This example is going to help us understand what evolution really is about later on. Now, it's for leaf insects now. And we have another very cool example, that being slave-making ants. So slave-making ants have some traits that make them like different from the other ants, and those are just like based on their conflicts, are just like made to control other ants because they have the chemicals to manipulate the other ants. For example, they have the colony, slave-making ant colony, and they're raiding the other colony. Their queen is going to go and take on the other enemy queen. It takes it out, and then it releases chemicals that makes the ants of the host of the colony that's being raided saying that it is their own queen. It's going to release those kind of chemicals. They didn't think of that. They just evolved to do that. So they have like slavery, and they with colonies. They take the eggs of the colony that's being raided and carry it to their own colony. When they hatch, they're gonna be thinking like this is our own colony. So they're gonna be like free workers, free slaves for these ants. Yeah, you can see in the image, they're just walking for them freely because they do not know. They'll be manipulated. They manipulate them. And the second example of insects being manipulated and insects manipulating each other is zombie and fungus. Zombie and fungus have a mind controlling ability. Yeah, cool ability. So they get inside a host ant and make it go specific distance above the ground. at specific distance above the ground, where it is best for them. The humidity level, the temperature level is best for them. So when the ant reaches that distance above the ground, it's just going to stop. It's being manipulated and it's going to just stop. And that fungus can just stay there. It releases chemicals and just feeds from the inside of the ant to release its sprouts, to release like its offspring, and then cycle will be done every again. Over again. The cycle will be done over again. So other zombie and funguses will be born during the same processes their parents did. It's just an ongoing cycle that they have. So all those stuff, like weird behaviors, where evolution affected not only the physical traits of those insects and those fungus, but also their like traits, how they behave and how they fight against each other. So literally, what the nature did is create some kind of insect that did something and create another kind of insect that counteracted each other, that countered each other, and gave them abilities that could manipulate, they could counter other ants' abilities. So that's just what nature is doing. It's not all about physical qualities as nature, it's about conflicts between species too. So, well, does evolution has a certain destination or an aim place where it is like where it is getting us towards, where it aims to get us towards, does have a certain destination, and that answer could be, and that thing could be answered with some few examples and some stuff for positive fact that it really has a perfect destination, an aim destination that it brings us towards, and not a random process. We have some stuff here. For example, human brains have grown larger and more complex over time, making the humans actually smarter than they were when they were first born. I mean, we are getting smarter as the generations passing. That's not the lie. We are getting smarter, and we have natural selection and adaptation, which are just making species and animals more perfect than they were before, fitting their environment better. And also, the last one being the single cell. We went from single-celled organisms that just crawl on the top of the Earth's crust to ones that now capture the space, to the ones that now learn the celestial objects. We went so far, so that would be like positive ideas about it. However, as any coin has two sides, we have a contra arguments too. The first one being that humans still have an appendix and wisdom teeth. So we don't need it. For example, I don't have an appendix. They cut it. They took it away from me. I'm still living, I'm still functioning fine. We don't need it. But if evolution was perfect, then why didn't it just remove the appendix and the wisdom teeth? And we now have it. We don't need it. And the second debatable thing is genetic drift. Genetic drift is essentially a random process. It's random. Like, it doesn't aim for anything. And of course, mutation too, it doesn't aim for anything. And the last one, we can say the extinction of 99% of all the species that ever existed. So now we are only living with 1% of the species that ever existed on the surface of the world, that ever lived. So if evolution is perfect, not just that it would like take care, it would prevent all those failures from happening. Not just that it would do that. So at the conclusion, with all these counter-arguments being stronger than the arguments, I could say that evolution is not actually bringing us to perfection, not literal perfection, at least. Yeah, of course. Evolution makes species perfect in a way for their environment, to fit their environment, for their survival. So evolution is doing that for their survival. For example, we have sharks. They haven't been evolving for, like, they're not evolving at all, almost. They're not doing anything special. They are just there, almost the same as how they've been. And that is because they are almost perfect for their environment. For them to hunt, for them to do anything, they're almost perfect for their environment. Not the perfect species, not literally. And now, at the end of my speech, I just want to talk about the future of evolution, where it is going, where it is leading us to. Well, when we talk about it, it is a really amusing and interesting topic, the future of evolution, which could be revolutionary. Some futurists really do believe that evolution could just go beyond biology, the limits of the biology, and in the process, turning humans into mechanical beings. Digital beings, turning us into digital beings, fusing us with AI. So they're already creating mechanical arms, mechanical legs, and now if they manage to somehow learn how the brain operates perfectly, they will be able to do that. Merging us with AI in the process. That is very interesting, very amusing feature, but also very terrifying at the same time. Thank you for your attention. This is my speech.